Hello and welcome back to the third rail. The Layout 2025 series continues. In the last episode, we laid and did an initial test of the main lines. Today, we'll spend some time with something I wasn't expecting to have to do, turnout maintenance. Then we'll install all the power required for the layout. We'll also cover a few related topics based on some of your questions along the way. Throughout the series, links to the track plan in several formats will be available in the video description. Given the length of this video, chapters are also set up for ease of navigation. Last thing before we set off, if you end up liking this video and you want to support the channel, please be sure to hit the like, subscribe and alert button before leaving today. Super thanks are also available if you feel the content deserves it. Whatever the option you choose will be much appreciated. Many thanks. Now let's head over to the room. And there we are. The layout looks pretty much as it did last time, bar one difference. It is that most wires are now out of sight. I have a feeling some of you might be thinking, he's finally decided to hide his wires. Hooray! To which I'll preemptively retort that the sight of wires still doesn't bother me. With my previous layouts, most accessories were located close to the edges, so I could get away with running their wires under the track, then along the sides with very little impact on the ride quality. Remember that everything I am doing here is temporary, so I want to be able to put things together or take them apart easily and quickly. Drilling holes and fitting or removing plugs would consume a lot of time, so I try to avoid it. This approach wouldn't work well on this layout, at least not in the terminal and depot, where we will have plenty of accessories in close proximity to each other. The ride would be rather bumpy and cause frequent contact loss or derailments. For these areas, I don't think there is a way around the wire through baseboard method. So, to keep a consistent look overall, I decided to run everything under the board on this occasion. I got the drill out and I cut little flaps in the mats, then drilled a hole big enough for the plugs to get through. I vacuumed the wood dust away with this nifty Amazon special, a dirt cheap Chinese cordless vacuum cleaner, which was perfect for the job. Then I dropped the wires through and repositioned the track. I also pre-drilled holes for contacts and switching tracks. This would have been a very fast process on its own, but I had only tested the turnouts manually when laying them, so I decided to test them with power as I went along to avoid having to replace or fix them later on. Until now, I had been mostly using older style M-track turnouts, which came with a few lots of track I had bought when I started the collection about 10 years ago. They are recognizable by their large lantern. These turnouts were manufactured until 1974, so do not fit perfectly with my 1980s collection theme. They still work perfectly, but a lantern can be a problem with some rolling stock, for example the Red Arrows or the Zeppelin, a few Märklin coaches produced in the late 1980s, and stock from other manufacturers. Basically anything with a very low ride height or longer than 27 centimeters. For all these reasons, I always wanted to replace them with the redesigned small lantern versions. These were sold from 1974-75 onwards, all the way until the discontinuation of M-track in the early 2000s. So I have slowly been building up a stock over the last few years, which I am going to use on this layout for the very first time. Remember this bit about old unused track from the last video? Well, this applies to turnout mechanisms too, and 50% of what I had laid needed some attention. This was no fun at all, and rather unexpected as they all seemed to work fine manually. For those among you who have been stockpiling track, and maybe even for those who haven't, I think it is worth going over a few common issues and fixes today. Let's start with how things should behave. A turnout should change over as soon as the control wire is grounded, be it through a control box or by touching the track. The changeover should be instantaneous. This behavior is critical to the reliability of automated operations. Obviously, a total lack of reaction would be a problem, but if the turnout required a longer pulse of current to change over, this would also indicate that something is not right. Various things could be wrong, but mostly fall under two generic categories, either normal wear and tear or the result of past human intervention. I have a faulty turnout here that we'll use as an illustration. There should be a cover on the base that is simply clipped on. It is not required for the turnout to operate properly, so don't worry if you are missing one of them. Let's take this one off so we can have a look inside. All turnouts or crossings have a similar working principle, whereby a solenoid actuates a mechanism to move the switch rails. The turnout should rest evenly on a flat surface, and a spring should be present. The spring bit doesn't apply to the crossings where the mechanism is different. We'll look at one of those in a bit. If the turnout wobbles, have a look at the ends. It is likely one or more of them need bending back in shape. Make sure the surface of the track bed is as flat as possible in the area of the switch rails. There are quite a few moving parts, so I like to proceed methodically whatever the state of a turnout. I start by checking the switch rail assembly can move freely. One should feel no resistance when moving it with the fingers. Any drag could be caused by corrosion or dirt that usually occurs in one of two areas, or even both. The area around the pivot for the switch rail assembly tends to rust. Dirt or debris can deposit under the fake switch rod at the front of the switch rail assembly. A previous owner might have applied oil somewhere too, which might have hardened over time, causing sluggishness. As a rule, no oil or grease should be applied to any part of a turnout or crossing. I found that a few squirts of contact cleaner loosen or blow rust or debris away without leaving greasy residues behind. Don't use the traditional WD-40 here, as leftover fluid can get sticky as it dries. You can also insert a thin bit of card or paper to help push stubborn residue out if need be. Also check there is nothing in the way of the tab holding the assembly to the base under the track bed. At that stage, if the problem was only dirt or rust, you should be able to see that the switch rails automatically go back to their set position when you move them with the fingers to one side, then release them. Try switching the turnout with the control wires multiple times. It might still be sticky at first, but then loosen up. You might get the odd miss, which would most likely be caused by leftover rust or dirt in hard-to-reach spots. A few more switch sequences should loosen things up. It would be better to install such a turnout on a spot where it is going to be used frequently, as it is likely to be more susceptible to corrosion if left idle for longer periods of time. If things don't work properly after a clean, then we need to have a look at the mechanism. The problem with that area is that a previous owner might have been tweaking things, sometimes rather enthusiastically, so you may find useful to have a working turnout to hand for reference. The spring is unlikely to be at fault if it is intact. If it is missing or damaged, then you would have to replace it. Märklin still makes the part. It is reference number E353080, usually sold in a bag of 10. The spring we see now is elongated at both ends and ideally should have been replaced immediately. My poor eyesight played a trick on me here. I only noticed after filming this part, and this will be rectified later in the video. The solenoids are rarely at fault either, but if one was damaged, it is interchangeable with any other turnout with the same small lantern design. So this excludes crossings, which use a different solenoid type. There is a small test that helps the troubleshooting at that point. Move the solenoid lever by turning the turnout lantern by hand. If it moves freely, then the spring side would have to be checked. If it catches at any point, the loop area might need some attention. If something catches, it is likely to prevent the changeover, or the turnout might need a longer pulse of current to complete it. The loop in which the solenoid lever is inserted under the track bed might be out of shape. It needs to stand at 90 degrees and be perpendicular to the rest of its assembly. This will need bending back into shape and should re-establish a smooth back and forth motion of the lever and lantern. If the loop is straight and things are catching, check the lantern is properly attached. The upper solenoid lever should interlock with a plastic lever under the lantern assembly. If that part is dislodged, you shouldn't be able to operate the turnout manually in both directions, or only partially. Finally, it could be that someone applied grease in the solenoid itself or on its plunger. A few squirts of contact cleaner inside the solenoid might help loosen things up. No used track comes with a full service history, so one has to be ready for the worst. Once a smooth back and forth motion has been restored, if things are still not moving, then it will be time to look at the spring side of the mechanism. I'll start by swapping the spring I should have replaced at the very beginning of the process now. The rod or latch attached to the switch rail assembly at the front might have been bent and will need to be straightened back to a 90-degree position. If this doesn't work, then we need to look at the pivoting lever attached to the loop I mentioned earlier. It might have been bent in various directions in an attempt to increase the spring tension. For example, the spring arm might have been pushed up or down. Here, a comparison with a working turnout might assist in establishing the shape to aim for. Whatever the adjustment, the spring must always clear the center contact rails or it will cause a short. You might even find that the spring is obliterated when this happens. And that's it. Our turnout is now operational. Let's have a look at crossings. There, the cleaning procedure for the switch rails is the same. The mechanism is different and less likely to have been interfered with. The connection between the solenoid lever and the mechanism consists of a guiding slot on the solenoid side and a pin attached to the base plate of the mechanism. We have two spring arms connected to a diagonal pair of switch rails. Each arm is connected to the base plate of the mechanism with a pin. When the lever moves, the guide slot will shift the pin and the base plate of the mechanism will move up or down. The movement will in turn move the spring arms by shifting their pin, and the springs will move the switch rails. All leaf springs at the end of the arms should be inserted through a hole in the rods attached to the switch rail assemblies. Given the construction, I would have thought it is unlikely that one of them becomes dislodged, but I found this very problem on one of the crossings I installed, so it is possible. In this case, the disconnected switch rail assembly wouldn't move. A more common issue has to do with the connection between the solenoid lever and the mechanism. If the pin or its base are bent, then the changeover will be heavy-going. It might also lift the plate on the mechanism during the changeover. An arm pin might become dislodged along its travels, and one or both connected switch rails wouldn't move. Usually you'd find that a pair of switch rail assemblies doesn't change over on a diagonal. Bending the pin base plate to an horizontal position should bring things back on track. There is also a possibility someone might have been a bit aggressive trying to adjust the leaf springs. There, my recommendation would be to dispose of the crossing. Once leaf springs have been bent past their limit, it is very difficult to adjust them back to their original tension, and the result might not last very long. That was it for the crossing. Finally, a couple of simple things. If you are missing connectors and you are unsure which color to use for the control wires, the connector for the round position should be red, easy to remember as both round and red start with the letter R. The connector for the straight position should be green. Using these colors would bring you into compliance with the Märklin system color scheme. If lanterns don't light up, remember that they only work if the trackbed is connected to ground on the transformer powering the lighting circuit, like here. We'll cover the multiple transformers use case later in this video. If a turnout operates properly and the lantern doesn't light up, more often than not, the bulb is simply a bit loose and needs reseating. This is checked by unscrewing the lantern assembly. The bulb then simply needs to be pushed in and should be held in place by a plastic support with a little clamp. If the support is broken, then the bulb will not work. The bulbs are still available to buy new from Märklin under reference number E600000. Compatible bulbs are also available from many third parties, some of which also offer LED equivalents in the same fitting. I might have managed to fix my turnouts and crossings using the method I covered today, but it is not always easy or possible, so I would strongly advise to buy a few more units than needed, just to be on the safe side. Needless to say, I would have been better off checking mine before installing them. You might want to think about allocating some time for this ahead of installation to avoid similar surprises. Back to the build. After everything was operational and with the track and wires back in position, I went round and labeled all solenoid wires to help when the time comes to deploy controls. I used a Dymo label printer bought specially for the occasion. I didn't know they were still in business. I can only recommend it. The layout was now ready for the next step, which is the installation of the transformers. I had done a detailed calculation of the power requirements in an earlier episode in the series called Power and Controls. There's a little link at the top. Based on this, I will need 3 driving transformers and 2 52VA lighting transformers. When using multiple transformers, it is important to ensure they are in phase. This will prevent sparks caused by the small short that occurs when pickup shoes cross from one circuit to another in analog. It might also save your digital equipment if you are using a system that requires an AC power source. Putting transformers in phase is a simple procedure that is only required for transformers fitted with plugs that can be inserted both ways in a wall socket, like these European plugs fitted on mine. If someone has fitted directional plugs, such as UK plugs, it might be worth opening them and check they are wired the same way. If they are, then you are done. But we have Euro plugs, so I'll show you the procedure. We need a multiple extension lead, preferably unplugged from the wall socket. The reason for this is that we are going to have to connect the outputs of 2 transformers to each other. Transformers run both ways, so in such a scenario, as soon as one is connected to the mains, the plug of the second one will be live and ready to discharge mains level voltage. Touching its pins would certainly hurt at a minimum, so safety first. We need to connect both brown outlets on the back of the transformers. Then we can use a light bulb and connect its wires to the red ports. We then plug both transformers into the extension lead. And finally, the extension lead can be plugged in. If the bulb remains switched off or is very dim, the transformers are in phase. If the bulb is shining bright, the transformers are out of phase. In this case, you'd have to unplug the extension lead and turn the plug of the second transformer around. Then try again. The bulb should be off or very dim this time. We'll need to proceed the same way with each additional transformer. You probably have noticed I had marked one side of the plugs with tape. I had done this on all the transformers when I set them up on the previous layout, so I already know which way to plug them in. I am going to move everything to my larger extension lead. And that's it, that bit is done. For lighting transformers, the procedure is the same, but using the yellow outlets instead of the red ones. In analog, I don't think this matters too much for those, but I might want to use them with electronic or older digital controllers, so better do them as well at this stage to avoid nasty surprises in the future. With all our transformers in phase, the next step is to configure common ground. Why do we need that? Let's look at our turnout again. It is connected to the lighting circuit on the transformer powering the layout. If I make contact with the track, the turnout track bed gets a ground connection and the lantern switches on. I am also able to operate the switch rails by touching the main line with the control wires. We might have a lighting and driving circuit on the transformer, but both share the same source. As we will use many accessories, using this configuration would deplete the power available for driving, so I will need to power the turnouts from one of the lighting transformers I have planned for the layout. Let's plug the yellow wire from the turnout to another transformer. And now let's make contact with the track again. The light stays off, and touching the rail with the control wires has no effect. This also means that control tracks wouldn't work. This is happening because there is no path to ground between the lighting transformer and the track. Now let's connect the brown port on the lighting transformer to the distribution plate I used for the brown connections of the driving transformer and track. The ground connection of both transformers and track are now joined. Let me place my turnout on the track, and the light turns on, and I am able to operate the turnout with the control wires. We now have common ground, and I will need to set this up for all transformers. I am going to live with this messy arrangement for now, but I'll make it neater at a later stage. Okay, next step for today will be to set up power circuits on the main line. I have planned to split the track in 3 sectors, each powered by a dedicated driving transformer, the outer loop, the inner loop, and a common sector for the station and depot. I could have used a single driving transformer, I think, but I wanted to be able to control these sectors independently. In analog, this can only be achieved with multiple controllers. We don't have a station or depot yet, but we can take care of the main lines. I cannot simply plug in additional transformers, as this would cause a short. The sectors need to be electrically isolated. With the 3-rail system, this is achieved by isolating the center contacts on each joint connecting separate sectors. At this stage, we have 3 connections between the outer and inner loop. One on the left here, then another one in the center, then finally another one between the 2 turnouts further down. All we need is a bit of electrical tape, which we'll use to cover the surface of the center contact on one track section so that it interrupts the current flow with the next one. You could also use some guard. We then reattach the track and we should be done. I'll do the same on the remaining joints. Let's test this. I can drive the locomotive on the outer loop. Now let's try and drive across to the inner loop. And we are stopping. Cool. Our sectors are indeed isolated now. I am now going to connect another transformer to the inner loop. Now let's apply power. And we are moving there as well. Now, we are not finished with track isolation, as we'll see in future episodes. But every time isolation is required, the same process will be used. Right, let me set up another train so we have something to watch as I give you an overview of the next steps to finish the video. There we go. So, it is time for me to crawl under the layout and connect all the power feeds I have laid to their respective transformer. I will do this off camera, and I'll give you a quick summary of what I have done at the beginning of the next video. Next time we will cover signals and control. We'll install the mainline signals, and I will use the opportunity to cover a few fix-it type topics some of you asked about. We'll then set up controls so that if all goes well, by the end of the video, we should be able to operate the main lines manually. I'd say things are about to get more interesting, but that's it for this installment. Thanks very much for spending so much of your time with me today. I hope you enjoyed the video, hopefully enough for you to give it a like and maybe subscribe if you haven't already done so, or even send a super thanks my way if you feel the video was worth it. Thanks as ever for all your support, and bye for now.